So, time travels, and I'm very pleased to open the third and the last session of this meeting about time. And what we have done so far, we devoted the first session to the beginning of time, and then the second one to ongoing time, which was supposed to be present time. And now we're going to deal with time travel. Time travel is a complex, rather convoluted concept. In brain research, we usually refer to memory as mental time travel to the past, to imagination or imagining as mental time travel to the future, and in academia, we leave no time for present. But in this session, we decided to combine various aspects of time travel, brain research, the first and the last, and then in between the arts, which are based, among others, on imagination, and which is time travel to the future. And I'm very happy to introduce the first speaker, Professor Uri Hasson. I could have spent 45 minutes talking about Uri, which would be time travel to the past, time travel to the future, and in between. Uri is a unique brain scientist. He combines keen interest in the arts, especially in cinema and literature, with excellent research on brain research. He did his PhD at the Weizmann Institute of Science. He then did his postdoctoral training at NYU, New York University. I had the pleasure of collaborating with him in both cases, and this was a very enjoyable collaboration. He's now a professor at Princeton, at the Department of Psychology at Princeton University, and he will be talking about time regained, how the brain accumulates and synthesizes memories as life unfolds over time. Uri, you have 25 minutes, out of which about half a minute is your title.
Which you read, so I can skip it. Where is the pointer? I'm very delightful and happy to be here. It was a wonderful and amazing day. And I want to start with the most important slide for me, at least. This is the people that really did the work. I'm only presenting, but it's a group effort, and there are many people involved. You cannot hear me? No? 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 I'm too tall for this mic. Now? Better? Okay. So this is a teamwork, and I want really to mention the people that did the work. I mainly want to mention Janice, Asia, Lauren, and Yara. And they're all amazing. So we talked a lot about time, and now we're going to talk about the human time. And you know, we all know the beginning, and we all know the end, right? And time flow, and we are somewhere over here. Each one of us is somewhere over here. Some are closer over here, some are closer over here, and some in the middle, right? And I want to start with a quote from Henry Bergson, the philosopher. The present contains nothing more than the past, and what is found in the effect was already in the cause. So what does it mean? Let's start with what is a present. Present is not a well-defined concept. Are we talking about a millisecond? Are we talking about a minute? Are we talking about a day? What is our present? And I'm not going to make it more clear. I want to say, let's define it now as the action I'm doing. And it can be saying this particular word or a sentence, or giving a talk, or being today in this symposium. So that's defined the present. And now what Bergson is saying, I really don't like to, I like to move. I don't know. Okay, that would be fine. Yeah, give me, yeah. Better? Okay. So what is the past? But Bergson is saying that this particular moment, whatever I'm doing, it depends about what happened before. and this is the past. And this is very different than physics. In physics, you don't need to carry the past. The past is going to influence what will happen now, but you don't need to remember it. So this is like a memoryless system. But in the brains, in the humans, you really have to gather your past. And this is really learning in memory. And the meaning is, each word I'm saying now, as the word table, I learn in meaning in the past. Each moving I'm doing, like talking, articulation, I learn how to talk in the past. So basically, all the things I'm doing now really depends on what I did before. And this is also true for the future. Each time that I'm going to do something is going to be related to what I did before. So now you can think about the present as something that connects the past and projects it to the future. And this is our brain. Our brain takes the current information, integrate it in what's happened before in order to understand what's going on, and then decide what to do. And now you can see that time suddenly is not as linear. It's more like a circle going on. And to give you an example of how memory is connected to everything we do, I will do what Yadin suggested as time traveling. And I'm going to go to my past and tell you a small story. Okay? And you know, and this is like traveling to the past and time again. We all know the example of Marcel Proust when eating the Madeleine cookies really forced memory. And for me, Jerusalem is my Madeleine cookie. Okay? I grew up over there. And this is me when I was really young. And this is my young brother. And this is a nice example when you can see that time actually makes you worse. Right? And this is my high school. This is actually elementary school. This is my high school. And this is where we are now. So I spent most of my time walking in the streets. And I was thinking, can I give one story that really related to this location? And I had many memories in mind, and I was saying, how come I've never been in this building if I lived here all my life? So basically, this is the President House, and this is where we are, in this building. And now we have this like huge complex around. And suddenly I remember that actually I spent many, many days of my childhood in this backyard. So what happened is, one day we found a donkey that escaped the Arab village, Silwan over there. And basically this donkey escaped, and unluckily we found him. And we were thinking that we can really take care of him. So we took him, and basically over here, this is where we grew up with the donkey. And if you know, this is the President House. So anyway, between the President House and out, and this is my friend's backyard, Aviv, we have the donkey. Till one day the President, security guard, came and complained, listen, the President cannot sleep, you have to take the donkey away. And I was reminded by this story, and then I say, okay, you'll never believe that. So I used Facebook. I found my friend Aviv, that this is his house, okay, and asked him to send a picture. So first he sent this picture, this is him, this is me, and this is an example that I can say actually that time can do you better, right? And then he also sent a picture of the donkey, Yosef. It's not Barbara Johnson. Barbara Johnson was a neighbor that lived behind over there, and basically this is the donkey. Okay, so let's think what happened here, right? When, you know, I remember now what happened to me when Yosef annoys President Navon at the time in 1981. Now, and that was in the past. And now we go to the present moment, 1918, and I'm retrieving this memory and remember it, and using words to tell it to you. And this is what we call memory reinstatement. And now I'm using these sound waves to tell it to your brains. But you don't have this memory, it's my memory. So now your task is to imagine what I'm saying. And if you imagine well, suddenly you can be back in time with me in 1981. That is a nice example our memory can combine past and future in every task we are doing. So the first part of the talk is going to be how we communicate memories to other people using storytelling. And the second part is going to be what is the connection between memory reinstatement and imagination, or between the past and the future. So let's think about communication. I have the brain patterns in my brain that relate to my thoughts and memories. And what I want to do now, I want to transfer it to your brains. So I'm using these sound waves. And these sound waves really couple our brains. Right? So now you're really connected to my brains using these sound waves. And my task is to take these brain patterns and to put it in your brains. So how do we do it? We use real-life stimuli. So I'm asking people to come to the scanner, and we scan their brains while they are telling stories. And we're going to give you a 20-second example of a story from a very talented storyteller, Jim O'Grady, that I really like. And this 20 seconds coming from the middle of the story.
So I'm banging out my story, and I know it's good. And then I start to make it better by adding an element of embellishment. Reporters call this making shit up. And they recommend against crossing that line. But I had just seen the line crossed between a high-powered D and assault with a pastry. And I kind of liked it.
Okay, so we scan people while they're listening to this story. And this is how we analyze it. We take the brain responses in one listener, using it as a model to predict the responses in another listener. For example, let's say this is the auditory cortex, and the responses in the auditory cortex going up and down as we listen to the story. Now I can see whether these brain responses will be similar in other listeners when they listen to the story. And we call it intersubject correlation, in a way measuring how similar is the brain responses of these two listeners when they listen to the story. And in more complicated analysis, you can think about it that I'm using one brain as a model to predict another one. So this is like 5 listeners, and we start to scan the brains before the story starts, when there is only silence in the scanner. And as you can see, the brain responses is very different from each other. Each one is going up and down, but in a very different way. However, as the story is starting, something amazing happening. So now you can see that the responses are really similar and going up and down in a very similar way across all brain areas in this brain area. So it seems that the responses are going up and down across all of you in the same way when you listen to the brain, to the story. And now you can ask, how extensive is this brain coupling? Is it happening only in the auditory cortex or in other brain areas? So basically, when we measure people listening to the story, we see that the responses are not only similar in the auditory cortex, but also in many other areas. So, for example, you can see this is the responses in the auditory cortex. You can see it's very similar. And now we go up to language areas. You can see that the response now it's different than the auditory cortex, but it's still similar across these two brains. And if you go to higher order areas, you see the responses become yet different again from these two brain areas, but they yet very similar across these two people. And we call this effect neural entrainment. And neural entrainment is a type of physical entrainment. And I will explain to you what is physical entrainment, and then we'll talk about social entrainment. Okay? Can you hear me or not well? Well, it's good? Okay. So what is physical entrainment? Think about it like 5 metronomes with like 5 brains. And similar to the brains doing rest, they're going to click at a different phase. Now I'm going to come and I'm going to connect them together. I'm going to connect them together by putting them on these 2 cylinders. And now there is a very small vibration that's going to these cylinders and move them. And this small vibration now is going to the wood and connect all the metronomes. You see what's happening? click together. And this is exactly what's happening now when I'm saying ba, 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 ba. All your brain responses, all your cortex will go up and down. But we don't want to be coupled to this like low-level auditory cortex, right? We want to be coupled to the meaning. I don't want to convey sound, I want to convey meaning. So we need to go above sound. So to demonstrate how important it is coupling on the basic level, let me start with an example of my son. This is my son Jonathan. Now he's 9 years old. I think now he's over his 9 months. And see how we invented a game with my wife, only to be coupled to another brain. It's not clear who is driving this game, whether it's my son or my wife. But what you can see that they really enjoy of being coupling to another brain. And now there is a communication between these two brains, and they become coupled on the sounds. They can use it to convey meaning and become coupled on higher and higher orders of information. So which aspect of the stimulus drive this coupling? Only the sound or the meaning? So how do we test it? What we do, we change the past. If I'm measuring the brain responses in particular brain area, it might be a response only to the moment. For example, I'm doing this brain area only care about the click, but it doesn't care what happened before. But maybe the responses depends on the sound of the syllables in the words, because you need to construct the word. Or maybe the responses depend on the words within a sentence. Or maybe the response depends on the meaning of sentences before. Or even it depends what's happening at the beginning of the story. You can think about these responses as have no memory. It doesn't carry the past. It only cares about the present. Where the responses are very, the past start to influence more and more and more, and they have more and more memory. So how do we check it? We simply change the past and see whether it changes the responses in the moment. For example, I can take the story and play it backward, and then it will sound something like this. Okay, so while I'm preserving the acoustic, I remove the meaning. Or I can take the words in the story and then scramble the words and have a list of words.
An animal, asserted fact, and wait on Pie Man, then she'll be my stories.
Oh, I can take the sentences and scramble the sentences.
And they recommend against crossing that line. It says, Dear Jim, good story, nice details. Didn't you only know about him through me?
And can do the paragraph and so forth. And what we see that if we have only sound, you see alignment across people. This is how people are similar, only in these early auditory areas. And if you have words, you get some of the early language areas become aligned. And if you have sentences, some of the higher order language areas. And in paragraph, you get more and more of the system. And if you put all of them together, you get a very nice timescale hierarchy. And let me zoom in so you can see the hierarchy. You can see that if you go backward in the brain or forward in the brain, you can see this hierarchy. And this hierarchy means that these early areas will respond to all sounds, reverse speech, word, sentence, paragraph, and full story in similar way across all subjects. And if you will move to language areas, only words or above will drive this reliability. If you will go even further into the hierarchy, you need a sentence or more to drive similar responses across people. And if you go even higher in the hierarchy to the blue areas, you need full stories or paragraphs to drive this reliable activity. So you can see the hierarchy of timescales. With this area, really integrate information over a very short timescales of milliseconds, and then information is slowly, as you move up the hierarchy, start to integrate sounds to words, words to sentences, sentences to ideas, and ideas to stories. So now let's focus on these higher order areas. They were also mentioned today in the default mode network This is areas that really care about meaning. And how do we know that they care about meaning? We did the following experiment. We took a story in English and translated it into Russian. And now we have very different words and sounds to communicate the same meaning. And now I'm comparing the responses between English listeners that are listening to the English story and Russian listeners that are listening to the Russian story. And what we see that these early areas that care about the sound of words do not respond similarly across them because the words and sound are very different. However, these other areas respond very similarly because the meaning conveyed between the story and the translation is very similar. So far we only talked about what's happening in your brains, in the listeners. So now let's move to talk a bit about the speaker. We did the exact same experiment. We asked the speaker to tell a story, and we scanned his brain, and then we took the sound and played it to listeners. And now what we did, we used the speaker brain as a model to explain what's happening in the listeners. And if you think about it, speaking, producing words is very similar, very different than comprehending words. But often we ask how the brain responses while I'm talking are similar to your brain responses while you're listening. And what we see that indeed, basically your brain responses as a listener are very similar to my brain responses in a speaker. And I can also tell you that the better you get me, the more similar your brain responses to my brain responses. So if now you are totally confused, I know that your brain responses is very different than mine. And if you click with me, I know that your brain responses become very similar to mine. So now, when we talk about communication, let's see how we can use it in order to take a memory from my brain and put it in your brain. So we did the following experiment. Right? So basically what we're trying to do, I'm trying to take a brain pattern from my brain and associate it with my memory and put it in your brain. Okay? We did the following experiment. We asked people to watch a movie for the first time in their life. We took a TV series. So how many people watched this episode? Okay, so for few of you, I'm going to trigger a memory. For the other, I'm going to provide a new thing to remember. And I'm going to give you again 20 seconds in the middle of the movie. The movie was 50 minutes.
What about these suicides then, Sherlock? Thought that'd be right up your street. 3 exactly the same.
4. Must be a 4th. There's something different this time.
A 4th?
Where?
Brixton, Norriston Gardens.
What's new about this one? You wouldn't have come to get me if there wasn't something different.
You know, they never leave notes. Yeah. This one did. Will you come?
Who's on forensics?
Anderson.
Doesn't work well with me.
Well, he won't be your assistant.
I need an assistant.
Will you come?
Well, please, can't be right behind.
Thank you.
Brilliant! Yes! 4 serial suicides and now a note. It's Christmas. Mrs. Hudson, I'll be late. Might need some food.
I'm your landlady, dear, not your housekeeper.
Something cold will do. John, have a cup of tea. Make yourself at home. Don't wake up.
Okay, so we scan people's brains similar to what happened today when they encode this thing into memory. And now we give them the opposite condition, okay? They have to lay in the dark in the scanner. There is no stimulus coming in. And we only ask them, use your memory now to tell the story of the movie to another person. So basically, now they have to use language in order to take their memories, reinstate them, and transfer them to another brain. And I'm going to play a recording of a subject that's remembering this beginning of this scene.
Miss Hudson comes in, asks if everything looks okay, and she picks up the newspaper and she's asking Sherlock about the murders that have happened. Sherlock briefly looks outside and he sees that there are cop cars, and he says that there's been a 4th murder, and something must have been different, so that's why they're there. And
Okay, and then we take this recording of one of the people that record, we had 17, we took one of them, and then we sent it to a group of listeners that never watched the movie. This is the communication part that we talked about. And then we asked how similar is the brain responses to the brain responses of the speaker while he really experienced and encoded the memory. Okay? So this is an example of one speaker that remembered the story. The story took 50 minutes. It took 22 minutes to remember it. This is each particular scene. You can see that it takes more time to view than to tell, so there is some compressor. You can see that remembering the movie very detailed. She hardly forgets stuff. Sometimes she forgets, but she mainly remembers really well. And sometimes it's out of order, but it's mainly in order. This is all 17 subject remembering. You can see that some subjects were very efficient, 12 minutes. We have one subject that it took her about 45 minutes to tell a 50-minute story. Okay? Only young people in Princeton, I cannot do it at all. But even the ones that were very, very efficient, we still remembered most of the details. Okay, so now what we can do, I can look on your brain patterns when you see the thing in encode, and the brain pattern when you remember it. And I'm doing each scene by scene, and I'm comparing it to a baseline, and I'm comparing your responses when you see one scene and your responses when you remember another scene. So okay, I'm looking for reinstatement of this particular pattern in this particular moment in the movie. Okay? So we're looking at encoding and reinstatement. Okay? And basically we see how we use words to reactivate responses that happened in the past. And what we see a very strong reinstatement effect, meaning that I can really replay the movie in my brain while speaking about it. So I have a memory of the movie, and when I'm speaking about it, I can really replay it in this outer ends. I'm not replaying it in the visual cortex. It's not a visual imagination, it's more semantic imagination. And now we can look on what happened in the listeners when they're listening to me describing the movie. And this is the communication part. And what we see to our amazement is that I can see these activation patterns in the listeners when they're listening to me describing the movie. So it's like by describing the movies, they start to reimagine it themselves. And if I want to see how good it is, I can look now whether the listeners listening to the story are similar to myself when I watch the movie. Right? And this is the imagination part relative to the encoding, and you see that it's very similar. So basically what you see over it, it's pretty remarkable. You can see that I had an experience in the past of, let's go to the donkey example, for example. I have an experience in this backyard of raising Yosef the donkey and interrupting the president. By speaking about it, that reactivate these experiences that really happened to me when I was with Yosef. And now by listening to me, you have these experiences in your brains. And the pattern is very similar. And it means that me remembering and you imagining are very similar and use very similar brain mechanism. And you can see the connection between the past and the futures in this particular example. Another thing that is really interesting is that, this is what I was saying before, the more you understand me, the more your brain responses are similar to the brain responses of me while I watch the movie. And if you look on all the other people that watch the movie, you're going to be most similar to me. That's interesting. That means that you can think about memory as me taking the experience, encode it in my brain, based on my own understanding and background and understanding, and give you this compressed memory. So you think about memory is like taking orange juice, turn them into a juice, and only give you the essence of the story. And you, because you are bound to the way I'm remembering Yosef the donkey, you are bound to this experiment. If you're going to ask President Navon about it, or sadly he died 2 years ago, so maybe ask his wife, we know that she's still alive, maybe she will have a very different memory of this event. And then your brain will look like her brain, not like my brain. Okay? But there is another thing that is even deeper, right? How come that you understand what I'm saying, though you weren't with me? And I think this is because we have a similar background. So, you know, if I will, instead of saying the word cab, I will say acne carrot. Only the British people will get what I'm saying. Or if I will say the word Astano instead of Lafa, only the people from Jerusalem will understand what I'm saying, right? So we're all developing a context together. And now there is something very deep. It means that in order for you to understand me, to understand my memories, you have also to share my past. And that has to complicate the model a bit. Because this is saying that although we would like to be coupled with other brain, and it's very easy to be coupled on the sensory level, to be coupled on the meaning level, we have to share background. Because there is like a filter of prior beliefs by which you understand what I'm saying. So we wanted to test this filter, and we did the following, and that will be the last experiment for this lecture. We took a story by J.D. Salinger. And this is a very fun story. It's very ambiguous, but the story is the following. Husband lost track of his wife in the party. He coming home by himself, very worried. In the middle of the night, he's calling his best friend, asking, "Did you see my wife?" Next to the bed, there is a mysterious woman. And Salinger is very smart. He never tells you her identity. So there is an ambiguity over there. Is it the wife? She have an affair? Or is it the girlfriend of the good friend and the husband is a bit crazy? So as a good scientist, we ruin the story. Okay? We remove the ambiguity. For half of the people, we say, this is the wife, she have an affair. Okay? So now this subject coming with this particular filter or knowledge about the world. For the other group, we were saying, this is not the wife is very loyal, this husband is very jealous as crazy. So now they have a very different filter. And then we play the exact same story. And again, I will give you 20 seconds from this story.
Did you happen to notice when Joni was leaving? Did you happen to notice if she left with the Alvogans by any chance? The gray-haired man looked left again, but high this time, away from the girl, who was now watching him rather like a young, blue-eyed Irish policeman. No, I didn't, Arthur. And didn't she leave with you? No, Christ. You didn't see her leave at all then? Well, no. As a matter of fact, I didn't, Arthur.
Okay, so first it's important, if you look on this, it's not that the two groups understand the story in a different way. We all understand what was the question, did you see my wife? We all understand that the friend say, I have no clue. Right? So we all understand the situation. But on top of it, we also believe that the friend is really lying in one context and he's telling the truth in another context. And this like small difference really make a big difference, right? And what we saw that if you believe that the wife have an affair, you're going to be more similar to the people that believe like you that the wife have an affair, and slightly different but statistically significant from the people that believe that the wife is jealous. And if you need to guess between two groups, like pro and con, the chances will be like 50% that it will be in one of the groups. We knew about 85% accuracy, whether in one context or the other, based on how similar you are to other people. So that's like a big effect. So let's summarize. I want to conclude with these two observations. First, I want to take a sentence from Ubuntu philosophy and say, I am because we are. A person is a person to other persons. And this means that you're connected to other brains. You change who you are, and then you change who they are. So in a way, my memories in this lecture are your thoughts. And your thoughts are my memories. And you can see again the circularity of time and meaning. And then, if you take it into account, it's something really interesting in merit. It means that your connection with other brains and your memories is in a way to fuse the past and the future, to advance us forward in a nonlinear, quasi-circular manner. And I think this is the main difference between physical time and psychological time. Thanks.
Thank you, Uri, for a beautiful lecture. There are many things I remember about the talk so far, but there is one sentence I'm not going to forget ever. Yosef the donkey interacting with the president. I repeated several times. So we have time for 2 questions, not about Yosef, not about the president. Question number 1.
Yes.
But brief questions, because the answer is going to be
very brief. I don't know about the answer. How far you can go with planting memories in people's brain?
Well, I will say, in this circular way, most of the things we are saying we heard from other people, and we are less original than we believe we are, right? Because we are all connected, and we all form. And this is why the lectures in the morning, Professor Bauer was so amazing, because what he was trying to tell us, he was trying to tell us history is storytelling, in which partly you take facts, turn them into stories, tell them to other people that become your facts. And this is exactly this mechanism that you can see over here.
You'll get it afterwards. You're first. But
Okay, so quick question. You talked about the memories in the past, before the present. My question is, in the brain, are they stored in some kind of chronological order? Or is it a different system of arrangement of these memories?
Okay, so we have a very different view. We don't think there is a memory system. We think that there is a memory in each system. The fact is, the past is gone. It will never repeat itself. Why do I care about the past? I only care about the past to do future actions, right? So then there is a strong connection between the past and the future. And this means that the same neurons that do the current processing also do integration with the past. So in our timescale hierarchy, it means that each brain area process information and accumulate and integrate and synthesize. So they're all happening together, and there is not memory system that it's different from the processing system. It's there, very different than a CPU or computer in which memory is separated from the processors in the brain that are going together.
what Uri is referring to memory which is episodic, which means memories of experiences, memories that you can reenact and reprocess. But there are cases in which some kind of memories which are more procedural or tasks that you repeat, like skills that behave differently, but this is not this type of memory. So I promised one person and that's all. Okay.
Did you make any control experiments in your research?
Yeah, many.
But you didn't mention.
I mentioned few, and I didn't mention most of them, and also I removed all the math and all the neuroscience and the way we do the analysis. There is many control, a lot of statistics. I refer to our webpage to read, or you can come after me to talk to me about the controls. And
yeah. So we have to proceed, although it's a beautiful topic. So you look so okay. Weak heart.
Could these techniques be used for brainwashing, for instance, putting a tape in a prisoner's room and plant something in his mind and he will believe it later? Because this is very dangerous.
I had a talk about it with a friend during the break. Anyway, listen, you're always connected to the outside, and you are brainwashed by the outside. Okay, you are shaped by the people you are connected, by ideas you are listening, by your society, by the shared background. So in a way, you can think about this thing as revealing the underlying mechanism by which, but it's already happening in any case because your brain is connected to the outside. But knowing stuff can improve stuff. So there is this dangerous gray zone over there.
Okay, I really regret that we have to leave this, but we are moving quickly.